Welcome, curious minds. Imagine you're planning to build a house. You start simple, right? Maybe a cottage.
Mm,
But what if, over time, you realize you need a skyscraper? You wouldn't just pile more bricks on the cottage.
absolutely not. You'd need a completely different plan, a different foundation.
Exactly. And that's what we're diving into today, that architectural journey, but for data platforms.
Right.
Our mission is to unpack how these powerful architectures evolve, specifically using Delta Lake on Databricks. How do you go from that simple setup to, well, an enterprise-scale solution?
Yeah.
We've got this comprehensive technical design document as our blueprint. It outlines how you can build solutions to be scalable, ensure data quality, and crucially be cost-effective. Okay,
Yeah.
let's get into it.
Indeed. And what's really fascinating, I think, is how this document guides you. It clearly categorizes projects by complexity.
Right.
It lays out this practical path so organizations can start small, build that initial cottage,
Right.
and then scale up confidently without having to tear everything down and start over.
Which is huge.
Yeah.
Nobody wants to do a total rebuild.
Nobody. And it raises that key question. What actually defines these different levels? Simple, medium, complex. What do they really mean in practice?
That's the perfect place to start. So the document gives us this clear framework, 3 distinct project tiers. Can you maybe walk us through them? Give us a sense of the typical use cases and maybe the why behind each one.
Absolutely. So we're looking at simple, medium, and complex, and it's less about just labels, more about the scale of the challenge you're tackling.
Okay.
So simple. This is really designed for, let's say, limited data volumes, pretty straightforward ingestion needs.
Like that cottage.
Exactly like the cottage. Think daily CSV files coming in, maybe feeding some basic BI reports, business intelligence. Yeah. The stakes are, relatively low initially, and the main goal is just getting some clarity.
Got it. Simple needs.
Then you have medium. Now you're handling more data, maybe moderate volumes, and often you're mixing batch and streaming data.
Okay, so things are getting a bit more dynamic.
Right. You're building something bigger now, maybe that multi-story home. A good example might be integrating, say, real-time IoT data Internet of Things with your ERP data, your planning data for dashboards that need to be near real-time, more moving parts.
Right, more plumbing, more electricity, like you said.
Exactly. And then there's complex. This is the skyscraper.
Okay.
This is for true enterprise-scale operations. We're talking very high volume, lots of different data producers, and lots of consumers, plus really strict governance requirements.
So compliance and all that comes heavily into play.
Big time. Imagine building a full-blown data warehouse for the entire company, or maybe a critical machine learning feature store that's feeding essential AI models. The complexity here is, well, it's exponential compared to the others.
That makes perfect sense. And it really highlights that it's not one size fits all. Trying to build a skyscraper for simple reporting task is just as bad as trying to run a global bank on the cottage's foundation.
Precisely. Over-engineering and under-engineering are both pitfalls.
So, okay, once we figure out which tier we're aiming for, simple, medium, or complex, how does that choice really impact the actual data architecture, the components themselves?
This is where it gets really interesting, because the document, it provides this fantastic table, almost a visual guide. It shows how the core Databricks components aren't static things. They evolve across these tiers.
Okay.
Think of it like the foundations, the walls, the wiring of our building metaphor. They change based on the building size and what it's used for.
Right.
We can go through some key ones, maybe show that progression.
Perfect. Yeah, let's do that. Let's start right at the bottom,
Yeah.
where all the data actually lives.
Yeah.
The storage layer.
Mm-hmm.
How does that evolve?
Right, storage. Well, the strategy here really reflects those increasing needs for separating data for security and for resilience. It has to grow.
Okay.
So in a simple setup, you might just start with DBFS, that's the Databricks file system, or maybe Azure Data Lake Storage Gen 2, ADLS Gen 2, basically for your raw and processed data. It's like one big storage closet, easy to access.
Pretty straightforward.
Then, for medium, you're likely still using ADLS Gen 2, but now you're adding directory-level access control lists, ACLs.
Okay, so like adding locks to specific rooms.
Exactly. You're separating data zones, maybe for different teams, different projects. You need more control over who gets to see what data.
Makes sense. More granular control.
And then for complex, this scales up significantly. You're looking at multi-region ADLS Gen 2, and critically with replication specifically set up for disaster recovery.
Okay, so redundancy across different geographic locations.
Precisely. You're building backup facilities in different cities, essentially. essentially. This is absolutely vital for ensuring your data is still available, even if something catastrophic happens in one region. If one data center goes down, your business doesn't grind to a halt.
That's a massive leap in resilience. Definitely sounds like skyscraper level thinking.
Yeah.
Okay, so that's storage. Next, how does the data actually get into the system? Let's talk ingestion. How does that process change?
Yeah. Ingestion. It really moves from being like a basic drop-off point to a high-speed, super reliable delivery system. For simple projects, you might just be using manual copy-y into commands or maybe Databricks autoloader. But just for, straightforward daily batch ingestion, think of it like the mail arriving once a day.
Got it. Scheduled delivery.
Then for medium, that autoloader gets more sophisticated. It's configured for continuous file detection and incremental ingestion.
So it notices new files arriving almost immediately.
Exactly. It's more like having packages delivered as soon as they hit the warehouse dock, not just at the end of the day. It processes data in smaller chunks more frequently.
Okay, more responsive.
And then for complex, you're moving into continuous streaming ingestion, often from sources like Azure Event Hub or Kafka. These are like dedicated high-speed conveyor belts constantly feeding data into the system.
Real-time feeds.
Real time. And you add crucial features like checkpointing so the system knows where it left off if there's an interruption. And very importantly, the promise of exactly once guarantees.
That sounds critical. What does that mean exactly?
It means that every single piece of data is processed only once. No duplicates, no omissions, even if there are system failures or retries along the way.
Wow.
Which is absolutely essential for things like financial transactions or critical sensor readings. You cannot afford to count things twice or miss them entirely.
Fascinating. That shift from batch to continuous streaming with those guarantees, it really is like going from sending daily letters to having a live, reliable video conference. Okay, so the data is stored securely, it's ingested reliably. Now, once it's in Delta Lake, how do we shape it, organize it, make sure it's trustworthy and ready to use? Let's talk Delta Table Management.
Right, and this is where Delta Lake's core features async transactions, schema evolution, time travel really start to shine. They're leveraged much more deeply as complexity grows.
Okay, so how does that look across the tiers? Let's start with the structure, the data layers.
So the layers evolve to provide more refinement and specific optimization.
Right.
In a simple setup, you typically see two layers. Bronze, which is just the raw ingested data, basically untouched, and silver, where the data has been cleaned, maybe deduplicated, transformed a bit. It's like a basic kitchen and dining room setup.
Raw ingredients, prepared meal.
Got it. For medium, you usually add a third layer, gold. This layer is specifically optimized for business intelligence reports and direct consumption by analysts or applications. It's often aggregated or denormalized for performance.
Okay, so now we have the pantry, bronze, the prep area, silver, and a dedicated serving area, gold.
Exactly. And then for complex, it can get even more sophisticated. You might have multi-hop layers, meaning data goes through several stages of refinement. Plus, you often see a dedicated feature store specifically for curated data ready for machine learning models.
So a specialized area just for ML ingredients.
Precisely. It's like a highly specialized gourmet kitchen now, with custom areas designed for every single process, ensuring consistency and quality for those critical AI applications.
Okay, layers make sense. What about managing changes to the data structure? Schema evolution.
Yeah, this is a big one. How do you handle new columns appearing or data types changing?
Right.
For simple, often it's just manual updates. Someone notices a change, they update the table schema. You manually adjust the house blueprint if you decide to add a window later.
Okay, manageable for small scale.
For medium, you start leveraging automatic schema evolution for new fields. So if a new column appears in the source, Delta Lake can often add it automatically. But you'd likely set up alerting so you know when unexpected changes happen.
So the blueprint adjusts, but it flags it for review.
Exactly. Now for complex, this gets much stricter. You still have automatic evolution, perhaps, but it's combined with strictly controlled schema policies.
Policies. Why this strictness?
Well, think about it. In a complex system with dozens of downstream consumers, dashboards, ML models, operational systems, and unexpected schema change, even just a data type changing can cause chaos.
Right. It could break everything that depends on it.
Exactly. It could corrupt reports, skew model predictions, potentially costing a lot of money or leading to bad decisions. So these controlled policies aren't just about preventing errors, they're about maintaining absolute trust and stability in your core data assets at scale. It's risk management.
That makes total sense.
Yeah.
Okay, what about going back in time travel?
Delta Lake's time travel is a powerful feature. How long you keep that history depends on your needs.
Right.
For simple, you might just keep the default, maybe 7 days of retention. Enough for basic rollbacks if something goes wrong with a recent load. Think of it like short-term memory for your data.
Okay, rewind a week.
For medium, you typically extend that, maybe 30-day retention.
Okay.
This is better for recovery for more complex issues and also useful for short-term audits. Now you have about a month's worth of history.
Better for compliance checks, too, maybe.
It's starting to be, yeah. But for complex, this often extends significantly, maybe to 90 days or even more. This is driven by stringent compliance policies like GDPR, HIPAA, and the need for deep lineage tracking. You need to be able to go back quite far to see exactly how data looked at a specific point in time for audits or historical analysis.
So it becomes your data DeLorean, like you said.
Yeah.
Critical for accountability.
Absolutely. And finally, under table management, let's talk optimization, keeping those delta tables performing well.
Right, because performance matters.
Always. In a simple setup, you often rely on manually running optimize and vacuum commands. Optimize compacts small files. Vacuum cleans up old, unreferenced data files. It's like you manually tidying up your house.
Okay, requires manual effort.
For medium, you move to scheduling jobs to automate this. So optimize and vacuum run regularly, maybe nightly or weekly, keeping things tidy without manual intervention. You've hired a regular cleaning service.
Better, more consistent.
And for complex, you leverage Databricks auto-optimize and auto-compaction features. These are typically always enabled. The system intelligently decides when and how to optimize the tables in the background, ensuring peak performance continuously.
So the house basically cleans and organizes itself.
Pretty much. It aims to keep things running smoothly all the time, which is crucial when you have high query loads or demanding SLAs.
That's a really impressive progression in just managing the tables themselves, from manual and reactive to highly automated and proactive. Okay, but how do we actually process the data within these layers and orchestrate the whole flow to get meaningful insights?
Right. This is about automating the heavy lifting, the actual data transformation work, and making sure it happens in the right order.
So processing and transformations first.
Okay. For simple projects, this often happens in Databricks notebooks, maybe triggered manually by a data engineer or run on a very basic schedule. You're kind of running the scripts yourself when needed.
Hands-on.
For medium, you typically move to using Databricks jobs and workflows. These let you define dependencies between tasks. Task B runs only after task A succeeds, and set up automatic retry policies if something fails. It's more robust, like setting up automated assembly line steps that can handle minor hiccups.
More resilient, less babysitting.
Exactly. And for complex, you often employ Delta Live Tables, or DLT. DLT is a framework specifically designed for building reliable data pipelines. It not only automates the processing, but also automatically tracks data lineage, enforces data quality rules during the pipeline run, and simplifies the management of batch and streaming data together.
So DLT is like having that intelligent assembly line that builds in quality checks and documentation at every single step.
That's a great analogy. It ensures the output is consistently reliable and makes managing complex flows much easier.
Okay, and how is all this sequenced? Orchestration.
Orchestration is about triggering and managing these workflows.
Right.
Simple might just be those jobs triggered manually or on simple cron schedules like run every day at 2 a.m.
Set it and forget it, hopefully.
Medium uses Databricks workflows more extensively to chain multiple tasks together and handle failures within the chain automatically. If step 3 fails, maybe it retries or maybe it triggers an alert, but the workflow manages it.
Smarter sequencing.
And complex scenarios demand even more sophistication. You're looking at event-driven workflows, often triggered automatically by data arriving in storage or landing in a message queue like Event Hub.
So processing kicks off instantly when new data appears.
Yes. And these workflows are typically integrated into CI/CD pipelines, continuous integration, continuous deployment. All the code, notebooks, pipeline definitions, is managed in Git for version control, automatically tested, and then deployed. This brings software engineering best practices to your data pipelines, ensuring reliability, consistency, and traceability at enterprise scale.
Wow, that really is a journey from hands-on, almost craft work, to highly automated, engineered self-healing systems. Impressive. And of course, as things get this complex, security and governance must become absolutely paramount, right? How does that layer evolve?
Paramount is the right word. Security by design becomes non-negotiable as you scale. You can't bolt it on later effectively.
So security and governance, how does it look?
Okay. For simple, you might rely on basic workspace, role-based access control, RBAC. General roles like admin, user. It's like having a single front door key for your house.
Basic access control.
For Medium, you typically introduce Databricks Unity Catalog. Unity Catalog is huge. It provides a centralized metadata and governance layer across all your workspaces and clouds. At this stage, you'd use it for managing basic table-level access controls.
Okay, so now you have specific keys for specific rooms managed centrally.
Exactly, and Unity Catalog makes that much easier to manage than trying to set permissions individually on files in the lake.
Right.
Then for complex, Unity Catalog becomes the absolute core of your governance strategy. You're using it for fine-grained permissions, potentially down to the column level or even row-level filtering, plus attribute-based access control, data masking.
Wow, very granular.
Extremely. And you're also using Unity Catalog for comprehensive data lineage tracking, seeing exactly how data flows from ingestion through transformations to consumption. Plus features like data discovery and tagging for better organization and compliance. It's like having security cameras, detailed access logs, and an inventory system for every single item in every room, knowing who touched what, when, and why.
That level of visibility and control sounds essential for enterprise trust. What about encryption?
Encryption evolves too. In Simple, you typically rely on the default encryption at rest provided by the cloud storage, like ADLS Gen 2. Your data is encrypted when stored, but the cloud provider manages the keys.
Standard protection.
For Medium, you often move to customer managed keys, CMK. You still store the keys in a service like Azure Key Vault, but you control the keys, giving you more authority and auditability over encryption.
More control over the keys themselves.
Yes. And for complex, especially in highly regulated industries, you might integrate with hardware security modules, HSMs, or use Azure Key Vault's premium HSM-backed keys. This provides the highest level of security, storing your encryption keys in highly secure, tamper-resistant hardware completely isolated from the main cloud environment.
Top-tier security for the most sensitive data. Makes sense. Okay, we've seen how the individual components evolve, which is crucial.
Yeah.
But you mentioned broader considerations, these non-functional requirements. These really define the maturity of an implementation, right?
Absolutely. The components are the what, but the non-functionals are the how well. They truly define the user experience and the operational reality.
So beyond just having the parts, what does this all mean for someone actually building and running their platform? Let's talk real-world metrics, like performance. How fast does it need to be?
Performance expectations ramp up significantly.
Okay.
For Simple, maybe the goal is just daily batch jobs completing reliably under, say, 2 hours. Good enough for next-day reporting.
Tolerable latency.
For Medium, especially with incremental loads, the expectation might be much faster, processing new data within maybe 5 minutes of arrival, enabling near real-time dashboards.
Much quicker insights.
And for complex, particularly with streaming, you might be targeting near real-time ingestion latency of under 1 minute. Data needs to be available for analysis almost instantaneously for certain operational decisions or real-time applications.
That's incredibly fast. Okay, what about scalability? How much data can it handle?
The scale just explodes upwards.
Right.
A simple system might be designed for maybe up to 100 gigabytes total data set size. Manageable.
Okay.
Medium systems need to handle significantly more, perhaps up to 5 terabytes of data per environment, like dev, staging, prod.
A big jump.
Complex environments, they might need to support ingesting and processing 10 plus terabytes of new data daily. The total stored data could be petabytes. That's truly massive scale, way beyond what many people initially plan for.
Wow. Planning for that kind of growth seems essential.
Right.
What about keeping it running? Availability and disaster recovery. DR.
This becomes increasingly critical and demanding.
I bet.
Simple is often just a single region deployment. If that region goes down, recovery might be manual and take time.
Okay, basic availability.
Medium usually involves configuring multi-region failover capabilities, maybe using storage snapshots or replication, aiming for a recovery time of under 24 hours if the primary region fails.
Better resilience. A day of downtime might still be painful, though.
It can be, which is why complex systems require a robust, geo-redundant architecture. DR failover processes need to be regularly tested, and you define strict targets, a recovery point objective or RPO, maybe less than 1 hour.
RPO. How much data you can afford to lose, right?
Exactly. Less than an hour means you lose minimal data in a disaster. And a recovery time objective, RTO, maybe less than 4 hours.
And RTO is how fast you need to be back online.
Correct. Less than 4 hours means your critical systems are operational again very quickly after an outage. Meeting these RPorto targets is absolutely critical for business continuity in many enterprises. It's expensive, but necessary.
Essential for critical operations. Okay, the elephant in the room. Cost management. How does that change?
Costs obviously scale with complexity, but the approach to managing them also matures.
How so?
For simple, you might just have a rough monthly budget, maybe under $2,000 USD. Basic monitoring.
Keeping it lean.
For medium, the budget grows, maybe up to $20,000 USD a month. And you definitely have cost alerts configured in the cloud platform to warn you if spending spikes unexpectedly.
More proactive monitoring.
And for complex, cost management becomes a continuous, dedicated effort. You're using optimized Databricks clusters with auto-scaling, leveraging spot instances where possible for non-critical workloads.
Spot instances. Those are cheaper, interruptible ones.
That's right. Big savings potential, but you need workloads that can handle interruptions. You're also likely using the Photon engine extensively for accelerating SQL queries, which can reduce compute time and thus cost. And you'll have detailed cost monitoring dashboards, breaking down spend by project, team, or workload. It's an ongoing optimization process, always looking for efficiencies.
Right. Constant vigilance on the cloud bill. Okay, we've covered components, we've covered metrics. Before we get to the core principles, I'm curious, in your experience, which of these transitions, like say going from manual optimize to auto optimize, tends to give a team the biggest immediate wow factor or relief?
Oh, that's a good question. Honestly, the automation pieces often get that reaction. Moving from manual optimization and vacuuming to scheduled jobs or auto-optimize is huge. Teams spend so much time just maintaining tables manually.
Right.
Seeing the system manage itself reliably is often a big relief. Also, implementing DLT for complex pipelines can feel like magic compared to manually stitching together dozens of notebooks and managing dependencies. It simplifies things dramatically.
I can imagine. Okay, so beyond those metrics, how do we really ensure the data itself is trustworthy and that the whole system is maintainable long-term? Are there other architectural things to consider?
Yes, absolutely. Beyond the raw numbers, these additional aspects are vital for trustworthiness and sustainable operations. Well, first, data lifecycle and tiering. Thinking about data temperature, hot, warm, and cold.
Ah, right. Not all data needs the same treatment.
Exactly. Hot data, recent, frequently accessed, maybe operational data usually lives in your gold tables, highly optimized for queries. Warm data, maybe 30, 90 days old, might be in silver, still accessible, but perhaps less optimized. And cold data, like older archived bronze tables, can be moved to cheaper storage tiers, maybe compressed, rarely accessed, but kept for compliance.
And this helps manage costs and performance, right?
Hugely, both cost and compliance. You're not paying premium performance storage costs for data you barely touch, but you still have it if needed.
Smart. What else?
CI/CD and versioning. This is critical as you scale. All your code artifacts, notebooks, SQL scripts, workflow definitions, pipeline configurations should be stored in a Git repository.
Version control for everything.
Everything. And you need a proper release pipeline. The pipeline should automatically test code changes, maybe validate schema compatibility, run data quality checks in a staging environment, and then deploy to production, with automated rollback if something fails post-deployment.
So a software engineering discipline applied to data pipelines.
Absolutely. It's not just good practice. It ensures reliability, consistency, auditability, and the ability to recover quickly from bad deployments, essential for complex environments.
Makes sense. Anything else on the maintainability front?
Yes, a formal data quality framework. You can't just assume data is correct.
Right. Garbage in, garbage out.
Always. So using tools like Delta Live Tables expectations, which are basically data quality rules defined directly in the pipeline, is key. Or you might build custom validation steps in your workflows. Checking for nulls, ensuring values are within expected ranges, checking referential integrity between tables.
Defining the rules for good data.
Yes. And critically, you need alerting on data quality failures. If bad data gets detected, someone needs to know immediately so it can be investigated and fixed before it pollutes downstream systems or reports. Think of these DQ rules as the bouncers at the club door. They check IDs and make sure only the right folks get in, preventing trouble later. Trust in the data is absolutely paramount.
Love the analogy. Okay, this has been incredibly insightful, mapping out that entire evolution. So let's distill it down. For our listener, maybe someone planning their own Delta Lake implementation or scaling their current one, what are the overarching takeaways? The key recommendations and core principles they should really carry forward, regardless of whether they're building that cottage or the skyscraper.
Yeah, connecting it all back, the document, and honestly, best practices in general, boil it down to several critical recommendations and foundational principles. These really apply across the board.
Okay, let's hear them. Key recommendations first.
All right, first, always enable schema enforcement in Delta Lake. Maybe allow schema evolution, but enforce it. This is your first line of defense against data corruption from unexpected changes. Second, use autoloader for ingestion for anything beyond the absolute simplest manual loading. It's built for scalable, efficient file ingestion. Third, implement Unity Catalog relatively early, especially as you move towards medium complexity. Centralized governance pays off quickly. And adopt CI/CD pipelines as you scale. Don't wait until things are chaotic. Fourth, automate your optimize and vacuum schedules. Don't rely on manual runs long-term. It ensures consistent performance and helps manage storage costs. And fifth, monitor proactively. Keep an eye on data freshness, job success failure rates, cluster utilization, and of course, costs. Don't wait for users to complain or the bill to shock you.
Those sound like very practical, actionable steps.
Okay.
What about the broader, maybe more philosophical core principles, the foundation for long-term success?
Right. These are more about the mindset and approach. Data as a product. This is a big one. Start treating data sets not just as files, but as governed products. They should have clear owners, defined service level agreements, SLAs, about quality and freshness, and clear consumption agreements. This shifts the thinking towards value and responsibility. Security by design. Build security and compliance in from day one. Enforce least privilege access, use encryption appropriately, embed compliance controls. Don't try to retrofit security later. It's much harder and often less effective. Automation and observability. Automate everything you reasonably can. Ingestion, processing, optimization, validation, deployment, and crucially, instrument everything. Add monitoring, logging, alerting, and lineage tracking to all critical workloads. If something breaks, you need to know immediately and understand the impact. Cost optimization as a continuous process. Treat cost management not as a one-time task, but as an ongoing discipline. Proactively use auto-scaling, explore spot instances, review usage patterns, and stay on top of cloud pricing changes. The cloud offers flexibility, but you have to actively manage it to control spend. Resilience and recoverability. Have clear, documented strategies for data recovery. Leverage Delta time travel, implement robust backup procedures, use cross-region replication where needed, and critically, test your disaster recovery plan periodically through failover drills. Don't just assume it will work when disaster strikes, prove it. Governance and compliance alignment. Use tools like Unity Catalog to centralize access control, metadata management, and audit trails. But also, actively map your architectural choices and data handling practices to your specific compliance requirements, whether it's GDPR, IEPA, CCPA, or something else. This isn't just about ticking boxes, it's about building and maintaining trust. And finally, future-proofing. Design your platform with extensibility in mind. Anticipate future needs. Maybe you don't need real-time streaming today, but design so you could add it later without a massive overhaul. Think about ML feature stores, advanced data sharing capabilities. Your architecture should adapt and grow with the business.
Wow, that's a powerful set of principles. Data as a product, security by design, automation, cost optimization, resilience, governance, future-proofing. It really frames the whole endeavor.
Yeah.
What a comprehensive deep dive this has been, charting that path from the simple cottage to the complex, resilient data skyscraper using Delta Lake on Databricks.
Exactly. We've seen how every component from storage and ingestion to processing and security needs to evolve thoughtfully as your requirements grow.
Allowing you to start simple, which is key, but grow confidently.
Precisely. And by really embracing those core principles we just discussed, treating data seriously, prioritizing security, automating relentlessly, managing costs, ensuring you can recover, meeting governance needs, and thinking ahead, you're not just building like a data platform for today. You're building a truly resilient foundation that can support whatever analytics and AI needs come next.
So as you, our listeners, think about this, what stands out to you from our discussion today? Maybe it's the jump in complexity required for true disaster recovery testing, or perhaps how granular that access control needs to become with Unity Catalog at scale.
Yeah, or maybe just the importance of automating those optimization tasks early on.
Definitely. As you consider your own data needs, think about where you are on that spectrum. Are you building that initial cottage, expanding to the multi-story home? Or are you already planning or maybe replanning that enterprise skyscraper? Which tier, which principles resonate most with your current reality and your future vision?
Good questions to ponder.
Absolutely. Well, that's all the time we have for today's deep dive. Until next time, keep digging for those insights.